We've now got to the main idea, the new system. There are already organisations working in the paradigm of the system I'm about to describe, and I'll reference some of them in this video. Once I've described the system, I'll talk about things we can do on the short-term timescale of the next few years to build the things we will need to implement it properly. But for the main, detailed description of the new system, it's best to think about it through the lens of the medium-term timescale of the next 30 years, because it's on that timescale that we can truly build this system. So what is the new system? In a phrase, it's bioregional cosmolocalism. This is a combination of two parts, bioregionalism and cosmolocalism. Neither of these are new things. The term bioregionalism was coined in 1975 by Alan van Nieuwkerk, and there are many groups working on bioregional development around the world, with the most prominent proponent at the moment being Joe Brewer. Cosmolocalism, for its part, was pioneered by Wolfgang Sachs in the late 20th century. There are now many cosmolocal networks, and thought leaders today include Michel Bauwens, Jose Ramos, and Vasilis Kostakis. There are certainly people with interests in both bioregions and cosmolocalism, so I was surprised to discover that, at the time of recording this video, Googling the phrase bioregional cosmolocalism turns up no results at all. This is surprising because combining the two concepts can create a powerful new system that can simultaneously help us get back within the planetary boundaries, allow everyone to access modern technology, and allow communities and cultures to develop in their own way. I'll briefly explain what bioregionalism is before going into cosmolocalism in more detail. To learn more about bioregionalism, I strongly recommend you check out the work of Joe Brewer and see whether there are any groups working on it in your local bioregion. As a quick overview, bioregionalism is the idea that we organise our systems, including our political, economic and agricultural systems, around bioregions, which Joe Brewer defines as geographic areas defined by the intersection of ecosystem boundaries, typically things like watersheds, mountain ranges and so forth, with human systems that have a coherent cultural identity. They are quite large areas, often with multiple ecosystems and diverse human populations, and because they are defined by both ecological and cultural factors, it isn't always completely clear where the boundaries of a bioregion lie. But it is this combination of the ecological and the cultural that gives bioregionalism its power, because it helps us organise our communities in alignment with the natural environment. While bioregions are defined at quite a large scale, there are smaller scale areas within the same paradigm, such as ecoregions and individual watersheds and ecosystems. So that's an overview of bioregions. I'm not particularly knowledgeable about them at the moment, so to learn more about them, you should look up Joe Brewer's work. In the rest of this video, I will describe cosmolocalism, about which I am much more knowledgeable. Cosmolocalism is an organisational system that connects local communities through global networks. It functions through many individual networks connecting local groups working in a specific sector. For example, there can be cosmolocal networks of factories, farms, or bioregional learning centres. Each local node only works within its local area, but they all share their developments through the global network. This creates a powerful collaborative development dynamic in which each member of the network can access the accumulated knowledge and experience of the entire network. It's a paradigm of economic organisation comparable to capitalism, which functions through many individual companies working in specific industries. But it's a very different paradigm because capitalism consists of many businesses competing to become the biggest and most profitable in their industry, whereas cosmolocalism consists of many local organisations collaborating via the global networks so they can each provide the best services to their local communities. I'll use an already successful cosmolocal network as an example to show what this means in practice. The exemplar network is Fab Labs, which is a network of makerspaces, places with the machines needed to, in their words, make almost anything. It was started in the early 2000s by MIT's Centre for Bits and Atoms, led by Professor Neil Gershenfeld. There are now thousands of Fab Labs around the world, from Boston to Bhutan. CBA set up the first Fab Labs, but then created a separate non-profit organisation, the Fab Foundation, to guide the development of the network. The Fab Foundation doesn't decide where Fab Labs should be built, and it neither funds them nor owns them. Instead, anyone is allowed to build a Fab Lab and join the network, so long as they abide by the Fab Lab ethos and rules. Fab Foundation's role is to support the network by facilitating collaboration between labs, encouraging members of the network to develop new initiatives that can spread through the network, and supporting network-wide initiatives as they grow. There are some key elements that help the network function. One is that the designs for everything built in a Fab Lab are uploaded onto the Fab Cloud, where they can be accessed by every other Fab Lab. As well as this, the equipment used in the Fab Labs is shared across the network and visible to people outside the network who might be considering building one themselves. There is an ideal Fab Lab setup on the Foundation website, but it isn't necessary for every lab to have exactly that equipment. The important thing is that every lab should have similar capabilities, so that anything you make in one lab, you can make in every other. Combined with all the designs being uploaded to the Fab Cloud, this creates the collaborative dynamic, because as soon as someone invents something in one Fab Lab and uploads the design onto the cloud, everyone else in the network immediately has the opportunity to make it in their own lab. They can, of course, adapt or improve the design, and if they do so, they must upload their improvement to the cloud so everyone else can use that too. Another important element is the Fab Charter. This is a document that sets out, in easily understood terms, the basis of the network, such as what it is for, what a Fab Lab is, and what rules Fab Labs must abide by. For example, the Fab Charter says member labs must be open to the public and can be used to prototype but not produce commercial products. Finally, the Fab Foundation actively encourages the labs to participate in the network. It has various projects to do this, such as video conferences and in-person events, and it helps spread new initiatives through the network. An example of such an initiative is the Fab Academy, which is a model of globally distributed education that combines online lectures with lab days supervised by local instructors. Fab Lab's organisational structure is very well designed for what it is, which is to say, a network of makerspaces based on an ideal version designed by experts. There are other kinds of cosmolocal networks that have different aims and as such are designed slightly differently. An example is the Transition Network, which is a network of groups trying to decarbonise their local communities through a multitude of different projects. But all cosmolocal networks include some core features, such as a non-profit organisation that runs the network itself, a charter or set of principles by which members must abide, and a range of initiatives that members can choose to take part in. A key characteristic of cosmolocal networks is that they strike a balance between ensuring the network itself remains a coherent whole and giving the local nodes it is comprised of enough freedom to develop in their own way. This is all well and good, but to have a real impact on the economic system, cosmolocalism has to scale up to commercial manufacturing. This can be done by adapting the Fab Labs model. For example, a factory network would have a charter, but rather than saying the factories should be open to the public, a factory charter might say member factories should only supply products to their local bioregion and should use democratic decision-making. Where Fab Labs should all have the same capabilities, factories should be able to use the equipment that gives them the capabilities they want to have. To give a concrete example, different types of clothing are useful in different parts of the world. A network of clothing factories should facilitate each local factory to produce the clothes needed in their area. They needn't be able to produce clothes only used elsewhere. But if clothes from another part of the world are wanted in their area, they can use the network to learn how to make the clothes locally, so they don't need to import them from afar. There's another important element of commercial scale cosmolocal factories that has many positive consequences, including massively decreasing society's negative environmental impact, which is of course absolutely essential. This element is regional circularity. As a quick background, the circular economy is a way of organising material flows through the economy so that wastes from one process can always be used as raw materials for another. In a truly circular economy, materials cycle endlessly around the economy and never become unusable waste. This simultaneously eliminates the waste problem and vastly decreases the amount of virgin raw materials needed, because all waste can itself be treated as a raw material. Obtaining virgin raw materials, for example through mining ores or growing cotton, has a huge negative environmental impact, so avoiding this is a big improvement. Many raw materials, such as metals and rare earths, are non-renewable, so in the long term they will eventually run out if we don't bring them into the circular economy. Regional circularity means the circular material cycles are confined to local economies, so that each region is circular independently of other regions. This not only greatly decreases total environmental impact, it also creates a new dynamic of regional self-sufficiency. To use the example of cotton clothing, once a clothing factory that serves a local area is built and the materials cycle is filled, so there is cotton in the factory, clothing in the shops, everyone has a complete wardrobe, and each of the links in the cycle is full, the region can become self-sufficient in terms of cotton clothing. There will be an ongoing need for energy and labour to keep the system running, but these can be provided locally. So long as the factory itself is kept in working condition and the cotton continues to cycle around the local economy, inputs of capital and cotton will be minimal. They are unlikely to be zero, because the factory will need refurbishment and there will be some leakage of cotton, but the overall dynamic of the system will be one of approximate self-sufficiency. You can probably now see why cosmolocalism and bioregionalism go so well together. If the factories are built to serve their local bioregions and the material flows are bioregionally circular, so the materials cycle within the bioregion, you get an economic system in which local economies of bioregions can be aligned with their local environment, materially self-sufficient, and connected to other bioregions through networks that enable them to share knowledge and experience collaboratively.